All right, listeners, strap in. Today, we are diving deep, and I mean deep, into the world of AI.
Deep learning, deep pockets, deep. Just kidding. But seriously, get ready to have your minds blown because we're talking about AI that's not just playing games or writing poetry, it's tackling one of the most fundamental fields in science, chemistry.
Chemistry, like beakers and Bunsen burners. What's AI got to do with all that?
Well, more like molecules and proteins. Remember those tiny building blocks we all learned about in school? Turns out they're kind of a big deal.
Okay, I vaguely remember something about proteins being important. Refresh my memory, what are they again?
They make up everything. Your hair, your skin, the enzymes that break down your food, even the hormones that send signals throughout your body, they're all protein.
Right, the building blocks of life. Okay, now it's all coming back to me. But how does AI fit into all of this?
Well, AI is now being used to understand and even design these proteins with incredible precision. It's like having a super-powered microscope that can peer into the very essence of life itself.
Now that's what I call a deep dive. And speaking of incredible discoveries, 2024 was a huge worry year for AI and chemistry.
You bet. The Nobel Prize in chemistry went to 3 scientists who are basically superstars in the world of AI and protein research.
3. Okay, this must be big. Tell me everything.
2 of them, Demis Hassabis and John Jumper, created this mind-blowing AI model called AlphaFold 2. Now, imagine a computer program that can take a protein, which is essentially a long, tangled chain of molecules,
Yeah, picture it.
and predict its exact 3D shape. That's AlphaFold 2. It's like having X-ray vision for molecules.
Hold on, back up a bit. Why is the shape of a protein so important?
Great question. Imagine trying to understand how a car engine works, but all you have is a jumbled pile of parts. You need to know how those parts fit together, their shape, to understand how the engine functions as a whole, right?
Makes sense. So the shape is like a key to understanding the whole thing.
Exactly. Proteins are the same way. Knowing their shape is crucial to understanding their function, how they interact with other molecules, what role they play in the body, everything.
And AlphaFold 2 can figure all that out, just from a chain of molecules.
Yep, and get this, it can do it with amazing accuracy, even for proteins that scientists have been struggling to figure out for decades using traditional lab methods.
No way. So how does it work? Does it factor in things like how proteins have evolved over time?
You're spot on. The source material mentions something called evoformer mechanisms, and that's part of it. It's incredibly complex, but basically, AlphaFold 2 looks at a protein's genetic code, kind of like its instruction manual, and compares it to similar proteins to understand how its structure likely evolved over millions of years.
So it's like AI is tracing a protein's family tree to figure out its secrets. That's wild.
It really is. It's like AI is unlocking the history books of life itself.
Mind-blowing. But predicting protein shapes is one thing. What about designing completely new ones? Is that even possible?
That's where our 3rd Nobel laureate, David Baker, enters the scene. He's a pioneer in the field of protein design.
Protein design, so like building them from scratch, that sounds even more sci-fi than predicting shapes.
It's pretty close to sci-fi becoming a reality. If AlphaFold 2 is like reading a blueprint, Baker's work is like designing and building a custom structure based on those blueprints.
Okay, so we're talking custom designed proteins here. What kind of applications are we talking about? This has to be huge.
Oh, the possibilities are pretty much endless. We're talking about more effective medicines and vaccines, tailor-made to target specific diseases without all those nasty side effects.
That's incredible. Personalized medicine taken to a whole new level.
Exactly. And it's not just medicine. Think about new biomaterials, stronger, lighter, more sustainable than anything we have today. These protein pioneers are revolutionizing industries, from manufacturing to energy.
This is seriously blowing my mind. So let's bring it back down to earth for a second. What does all this mean for the average person? What's the takeaway here?
These breakthroughs aren't just happening in some fancy lab somewhere. They're already impacting the world in very real ways. We're talking faster and more accurate disease diagnosis, leading to more effective treatments, and a deeper understanding of how diseases work at the molecular level, which paves the way for even more advancements in the future.
So it's safe to say AI is revolutionizing not just chemistry, but healthcare as we know it.
Absolutely. And potentially paving the way for a healthier, more sustainable future.
A future where we can not only read the language of life, but even rewrite it.
Now you're getting it. The possibilities really are mind-boggling.
It's incredible to think that with AI cracking the code of proteins, what other scientific mysteries are out there just waiting to be solved? It makes you wonder what groundbreaking discoveries are just around the corner.
That's the beauty of science, and AI for that matter. There's always something new to discover.
And discover we will. Thanks for joining us on this incredible deep dive into the future of AI and chemistry. Until next time, keep those minds curious, listeners.